The OSI model has been around since 1977. It is simply a set of protocols which govern the various aspects of networking. This Buzzle article presents information about the various layers of the OSI reference model. The various stages in computer networking can be compiled into the OSI model. Many protocols that correspond to the networking layers reside in the stages of the OSI. A network administrator must know the functions of these protocols so as to have a better understanding of the subject of computer networking. In the following lines we try and provide a fresh perspective on the OSI layers and Ethernet protocols. History of the OSI model. The work on the Open Standard Interface (OSI) reference model was started in 1977 by the International Organization for Standards. It was then decided that OSI will have two major components, a 7-layer model, and a set of specific protocols. The various issues on OSI design have evolved from a networking model called Cyclades. This also influenced the design of the Internet architecture. Since the inception of this model, the working of Internet technology has become very smooth. Before the advent of OSI, communication between different entities and different vendors was extremely difficult. This was because every vendor would use a different mechanism to establish communication between his or her set of devices. Therefore, intercommunication between the entities of different vendors became very difficult, and there arose the need to have a common standardized platform. This need forced the International Organization for Standards to have a viable and universally accepted platform through which the OSI reference model was born. OSI layers. Physical layer. The physical layer is at the bottom of this model. It deals with crude data that is in the form of electrical signals. The data bits are sent as 0 seconds and 1 second. 0 seconds correspond to low-voltage signals, and 1 second correspond to high-voltage signals. The mechanical aspects of communication, such as wires or connectors, come under this layer. The physical layer also deals with how these wires, connectors, and voltage electrical signals work. The process that is required for these physical aspects is also taken into account in this layer itself. Data link layer. The transmission of the data over the communication medium is the responsibility of this layer. The 0 seconds and 1 second that are used in the communication are grouped into logical encapsulation. This encapsulation is called a frame, and thus the data is transported in frames. The handling of these frames is the responsibility of the data link layer. Network layer. All over the world, there are many different types of Ethernet. These networks are connected to each other through various media. When a data packet wants to reach a particular destination, it has to traverse through these networks. Essentially, there are a lot of operations that are taking place between the connected networks. Also, the packet data which is traversing has to choose an optimum route, and the addressing of these packets has to be proper. The various operations between the networks, packet data issues, addressing and routing, are handled by the network layer. Transport layer. The transport layer ensures the quality and reliability of communication. The data packet switching is entirely handled by the transport layer. There are basically two types of packet switching: connection-less packet switching and connection-oriented packet switching. In connection-less packet switching, the packet data is allowed to choose the route in which it is going to reach the destination. Obviously, the packet itself can't do this. Physical devices like routers are mainly responsible for the behavior of packets, but the packets formed from the same datum can reach their destination in different ways. Whereas, in connection-oriented packet switching, once the route is decided, then all the packets have to follow the same path. An example of connection-less packet switching is text messages in mobile phones, while a direct voice call is an example of connection-oriented switching. Sessions layer. The sessions layer is mainly responsible for creating, maintaining and destroying the communication link. Protocol data unit, in which various protocols are defined and have to be followed during communication, are the responsibility of the sessions layer. The applications that use RPCs, remote procedure calls, are taken care of by the sessions layer. Presentation layer. There are various techniques of data compression which are used to send and receive optimized data. For example, if certain data is repeating itself a number of times, then it is logical to send it only once, and specify the number of times it is repeated. This bundling of the repeated data is one of the techniques of compression. The compression and decompression of the data is handled by the presentation layer. Also, encryption and decryption techniques used to thwart malicious attacks on data are handled by the presentation layer. Application layer. This layer comes into picture when there is an application used to process communication. Whenever a user invokes any application, all the associated processes are run. Many times, when an application wants to communicate with another application, then there has to be communication between these associated processes. The application layer is responsible for this inter-process communication. Protocols. OSI layer protocols. Application layer. DNS, FTP, TFTP, BOOTP, SNMP, SMTP. Presentation layer. SMB, NCP. Sessions layer. NetBIOS transport layer. TCP, ARP, RARP, SBX, NLink. NetBIOS network layer. IP, ARP, RARP, IGP, IGP. Data link layer. LLC. Physical layer. LLC. OSI layer model versus TCP/IP reference model. Senior No. OSI reference model. TCP/IP reference model. 1. Model was first defined before implementation took place. Model was defined after protocols were implemented. 2. Reliable delivery of packet data. Service interface and protocols were not clearly distinguished before. 3. Internet working is not supported. TCP/IP supports internet working. 4. Strictly layered. Loosely layered. Since the establishment of OSI, there has been a revolution in the field of communication. The entire industry of communication can find its backbone in this model.